So LED strip lights, they have been around for a while, and honestly, I think they're one of the best ways to light up a kitchen and a workshop. But I can't tell you how many times I've seen them installed badly. They'll droop, they'll sag, the color just is weird or patchy. That said, I totally get why, because there are so many LED options out there that it will make your head spin. Figuring out which ones to buy, how to power them, how to install them neatly can be really tricky, but I'm here to show you how I've done it in high-end homes in the past and how I'm gonna do it in my own kitchen. So this is the under cabinet light that I installed in my shop a little while ago, and it's a simplified version of what I'm building this week. It gives me perfectly even light at the miter station, and here, let me show you what it would look like without it. So as you can see, if I were to just rely on the overhead lights alone, my shadow would always be in my way. So we've got the exact same problem here in the kitchen, is that overhead lights are great for general lighting, but they're not ideal for task lighting. Adding LEDs under the cabinets will make cooking a lot easier and more pleasant. Kitchen cabinets are more complicated than the setup that I have out in the garage, mostly because they're broken up between different spots with the appliances here and the window over there, and I want all of them to function on the same switch. I'm gonna cover how to build this for new construction, obviously, but I also am gonna talk about how to retrofit old cabinets, as well as how to pick the right LEDs and drivers to go with them. Now, all this gets started in the wood shop, so let's head back to the garage. If you check out the lights that I have in my workshop, you'll notice this piece of plywood in front, and that's what's called a valance. A valance blocks the light from coming forward, and it also just makes it look a lot cleaner. It can be as simple as a strip of plywood, but I've got a design for the kitchen that I think will look a lot better. Making the valances is relatively simple. If you've ever made a drawer, this is essentially a flipped over drawer box. I dimensioned the lumber to 3/4 of an inch thick for the sides and the back, and then the front is gonna be 1.5 inches, and I'll explain why in a minute. But first I have to cut out a dado slot for a top panel. This top panel is going to cover up all of the wiring so that they're not exposed, but we'll also have access to it if we ever need to change anything. The top panel is going to be made out of 1/4 inch veneered plywood, and I want to make sure that I get that fit really perfect. My table saw blade is 1/8 inch thick, so it takes 2 cuts, and I like to sneak up on the second cut and make sure that it's exactly the same as the plywood that I'm using. Not all plywoods are built the same. It may say 1/4 inch, but it could be slightly thicker or slightly thinner. When I get that fit dialed in, all I have to do is run the rest of the pieces through at the same dimension. I also added in a feather board because I found that they were kind of sliding out a little bit as I was cutting, and it just helped keep it pressed against the fence. There's a bit of order of operations to cutting these when it comes to cutting them to length. I like to start with the front piece and cut that to the same width as my cabinet. These are the pieces that I milled a little bit thicker, and the reason for that is because I want them to match up with the face of the cabinet doors, not just the front of the cabinet body. With those front pieces cut to length, I now need to cut the sides, and I want to miter that joint, which is easy if it's at 3/4 to 3/4, but what we have now is 3/4 to 1.5 inches. So how do we make a miter for that? I mean, one option would be to just cut the miter and leave the end grain exposed, and that's totally reasonable. But there is a cleaner way to join these boards. The best way is to find the angle that corresponds with the two joints and cut that angle, but how do we figure that out? It's really not as hard as you would think. Basically, you take a board like this, you lay a board on top like that, strike a line like this, and then you connect this dot to this dot. Now, one thing to note is that you're actually creating two different angles here. So one board is going to be cut at one angle, and then the other board is going to be cut at the complementary angle on the other side, because you're not cutting cleanly through the middle of one of the boards at 45 degrees. To find this angle, you can either use an angle gauge or do what I'm gonna do, which is just take it over to the chop saw and try and cut that angle as close as possible. According to the dial on my miter saw, that angle was 35 degrees. So I subtract that from 90 degrees and I get 55 degrees. Now that number is the next angle that I need to cut, and when they match up, in theory, they should be 90 degrees. It goes without saying that I am using scrap pieces to cut this out with, not my final stuff, because I do want to check to make sure that it is 90 degrees, make sure that my saw is set up correctly. Once I'm happy with it, then I can start cutting the actual pieces. I reset the saw to 35 degrees and cut the ends off of all 3 of my front pieces. I then shift the saw over to 55 degrees to cut the side pieces. I'm just cutting one end of each of these and leaving them long for now. Because I got the dado in there, there is a right side and a left side, so I laid everything out and then marked them out just to make sure I didn't get confused. Now the difficult joints are out of the way and I can cut the sides to length with a miter. Because I'm joining 3/4 to 3/4 at the back, I'm just using a 45-degree miter. So set up a stop block at the right distance. They're all going to be the same length. So I can cut all 6 of those, as well as the backs, which are going to be the same width as the front piece. At this point, the valances are basically done, ready for glue up, but I do need an interior panel. So I dry fit all 3 of them and measure the centers, adding in the depth of the dado. I pre-sanded all the interior pieces to make things easier on myself, and now I can glue up all the parts, and this basically just snaps together with that interior panel. I did glue the interior panel in because it's made of plywood, so it shouldn't expand and contract at all. And then for the miters, just a little bit of wood glue on there, and I will tape them up with some blue tape until they dry. Now, I don't have a spline or nails in this, but the interior panel being glued in is going to basically act like a spline and hold this whole assembly together. Now, as I mentioned earlier, this is a fancier version of a valance, and there are certainly other options and other designs out there. I found ones online that you can just order to length if you don't have a full wood shop at your disposal, but if you do have a table saw and a miter saw, I think they're pretty DIY friendly, and you can just cut them to whatever size you need for your cabinets. After a bit more sanding, I ran around the inside with a chamfer bit and eased all the edges. So the trick to this whole design is having this empty space in the bottom. This is going to allow me to run wires on the inside as opposed to like in a visible area. But I do want to screw through these to connect them, and I need to have a little bit of strength there. So I decided to add in these 1/4-inch strips as backing so that the screws are supported when they attach to the bottom of the cabinet. All right, the valances are built and they're looking really good. They're sanded up, basically ready for finish. But before I apply finish, I'm gonna start wiring up the LEDs just to check to make sure everything fits right. Okay, I've tested out the LEDs with a cheap power supply and they seem to be working fine. The actual power supply is on order, and then I thought maybe I should go over all of the things that I ordered and the reason why. Because when you search LED strip lighting on Amazon, a billion things come up and it's really hard to know what to order. I'll list all these products in the description down below, but I wanted you to understand, because if you have a different application, you need to understand what all these little crazy numbers and letters actually mean, and it's not as complicated as you think. We're going to start by looking at the LEDs. That's the best place to start, is to buy the LEDs that you need. You'll notice that the more expensive LEDs will have a lot tighter packed LEDs in the row. And in this case, these are called cob LEDs. They're right up against each other and they're all soldered together, so they look really even when they're lit. The other thing to look at is the color temperature. The color temperature is very important. You want to match the other lights that you have in your house. Those function on a Kelvin scale. So if you see anything that says 6000 K, 4000 K, this is what it's referring to as the warmness or the coolness of the light. The lower the number, the warmer it is. The higher the number, the cooler it is. 4000 K is what I have in the shop. 3000 K is what we're using throughout the house, and all the light fixtures are gonna match. So we're going with 3000 K. The next thing in the list is CRI. This is going to determine the quality of light that you get from your LEDs. So CRI is a scale that goes from 0 to 100, and around 50, you're gonna have really muddy colors, and around 90 plus, you're gonna have colors that are much closer to what you'll see with actual sunlight. In other words, it's just gonna be a better quality of light. So make sure you look for 90 plus CRI. So now that we have the color temperature, the Kelvin rating, and the spacing of the LEDs, we start to look at the power. So this is rated at 24 volts, which means that we get 120 volts from the main power of the house, and we need to transform that into 24 volts. I'm not sure why they decided not to call them transformers, but LED drivers are called drivers, but they do transform the power to the voltage that you need. And in this case, this one matches up with the 24 volts that we need. Now, the only math that we actually have to do for these LEDs is calculate how much wattage that we're using. So the longer the strip of LEDs you're using, the more wattage it's going to take up. So if you're using 5 feet, it's going to take up less wattage than if you use 50 feet. So you see a number here that says 14 W/M. That's 14 watts per meter. So every meter of this, it's going to consume about 14 watts. So multiply the length, the number of meters that you're using, which is about 3 feet. Make sure that you have at least 10% more wattage from your driver. In this case, the driver that I've ordered is 96 watts. This whole spool will only take about 70 watts, so that's more than enough to drive these LEDs. I got something a little bit bigger because we're probably gonna drive more LEDs with it, but we'll save that for a different video. Okay, the last thing to talk about, the last product that I ordered were these aluminum channels and diffusers, and for that, let's just go back to the wood shop and I'll show you how they work. These aluminum channels are a really nice addition to any LED setup. Not only do they provide a lot of diffusion with their plastic covers, but these aluminum channels are easy to work with any woodworking tool. They make it easier to clean, and they also just look cleaner when they're installed. I drilled out a few holes for mounting screws, and then I want to countersink them so that the screw heads aren't sitting up. This is my favorite style of countersink to use on metal, and I'll post a link to it down below. The last change I'm going to make to this channel is to cut out the end, and this is going to allow me to drill a big hole to run the wiring through behind the diffuser, so it'll have a completely seamless look in the end. I deburred the aluminum with a file, and then I can install them into the valances. With those installed and the hole drilled out for the wiring, I can cut the LED strips to length, and any LED strip that you buy is going to have little markers on it to show you where you can cut them. On mine, it was about every 1.5 inches, and so I made it as long as possible and cut it along the line. When you cut along that line, it's going to leave the connections exposed. These are little copper connections that you can either solder to, or you can buy solderless connectors to go onto them. I prefer soldering. I recommend soldering. It's a more permanent solution. It's less susceptible to damage. It's just a lot stronger, but there are solderless options out there. Once I've pre-tinned all of my leads, I introduce the two parts together, lay the soldering iron on top, and they're fused with a solid electrical connection. Honestly, I think the hardest thing about soldering is just holding the pieces in place while you're trying to make the connection. In this case, I figured out that if I tape the two wires to a board, they're just a little more stable, and it made it a lot easier. Now, this is a step that I see people miss all the time, but it's always a good idea to cover up these connections with a bit of heat shrink tubing. So in this case, I got a little bit of clear heat shrink, and I just heat it up with a heat gun. It'll shrink over those connections and just make sure that they don't corrode over time or someone accidentally sticks a finger on them. Using some denatured alcohol, I can clean the aluminum rails and stick down the LED strips. I like to start at the far end, the opposite end from the wiring, and work my way back, making sure that there aren't any air bubbles at all and that the wire has as much room as it can possibly get. You don't want to put a lot of pressure on the LEDs themselves, so I've found that using a tongue depressor on the sides helps embed the adhesive without damaging the LEDs. So I like the idea of this being incredibly seamless, but I also want to make sure that if anyone goes to service these LEDs, they know how. So I did countersink 4 screws on the underside. They'll be barely noticeable, but it'll also be easy to recognize that you can take this apart to service it later. The last thing that I need to do on the valances is to cut out a little notch in the back, and this is to allow me to run the wires up the back of the cabinet. I've clamped 2 of the valances together to give me a more stable platform for the router, and it's just quicker in the end to cut both of them at once. In my previous video, I went into depth as to how I made these upper cabinets, and if you want to check that out, I'll leave a link right here. But the main thing to know is that I left a space in the back of about 1/2 inch, and that allows me to run these wires through. Now I need to cut a notch that corresponds with the notch that I just cut for the valances, so I made that again with the router and used a backer board so I didn't blow out the plywood veneer. And as you can see, it lines up pretty good. Now I can flip that cabinet around and attach the valance to the bottom of it. I lined up the valance, and then I can add a couple of these Surefoot clamps to hold it into place while I screw it all together. Now this is just a dry fit. I'm gonna have to take all this apart and obviously add the wires in, but it's always nice to have the screw holes established before you go and do an install. Now I can bring these 3 parts together, screw them together, because we gotta make some more cutouts on the back side of this cabinet for the wiring to go through. The routing at the bases was not the cleanest, and so I decided to pre-cut these ones before I took the router to it with a Japanese pole saw, and this is just gonna pre-cut the veneer and give me kind of stop lines as I route it out, and this worked so much better and came out a lot cleaner. All right, now you can see how all the electrical works. It's gonna come in through the wall here and go down and connect to this valance. Inside the valance, I'm gonna connect 2 wires together, run that second wire out around here and down into the other valance. This ensures that all the wired connections are accessible even after the cabinets are permanently installed. Now that the valances are completely done, I removed them, added some coats of Rubio Monocoat, and let those dry while I worked on the wiring in the house. Now the driver for the LEDs that I've been waiting for did not show up in time, so I ended up stealing the one from my overhead lights in the shop. All right, so I stole this driver from my under cabinet lights because this is one that can actually go in an attic and be tucked away because it's in a metal box and all the wiring's to code. If you use this kind of adapter, you gotta have it inside of a cabinet that you have access to so that it has airflow around it. So I'm gonna use this one here, and this one will go up in our attic. I'm not gonna go into too much detail about wiring up the driver, mostly because I had my electrician do it. It's suggested in the manual that you hire a licensed electrician, and I recommend the same thing. I need to find the low voltage wire that we hid inside of here before the drywall was done. And on my phone, we got a picture of this wall. And I believe it should be like right about there. What, am I losing my mind? Okay, I'm just gonna patch it. Well, this did not go according to plan. I thought I was losing my mind. I thought I knew exactly where it was, but apparently not. I should have just cut a big hole in the wall, but I had just patched another hole, as you can see, and I didn't want to do another one. But I did find the low voltage wire. It was hidden way down in the corner. I'm not sure if the drywall guys moved it or if I moved it, but I did manage to pull it out and patch that hole back up pretty easily. This wire is connected up into the attic. We ran it before we added any of the drywall, so it's easy for my electrician to reach that and tie it into the main system. Off camera, I taped and mudded the patch, and then I could start adding new wires. I'm using the same thermostat wire that the electrician used to run these low voltage wires. The same thing that you would run for a doorbell. It's just a 2-wire low voltage connection. And I made marks on the wall exactly where those notches that I cut out in the back of the cabinets align. So I just lined it up, nailed them on, and made it really easy to put the cabinets back on and not have to worry about them kind of slipping around behind there and causing the cabinets not to sit flush against the wall. And speaking of the cabinets, it's time to install them, and I needed help for this middle one from my neighbor Brian and my wife Ashley.
Hi Ashley.
Alright, so grab that. Nice. Okay, this is where it's gonna get. Excellent. Alright.
It seemed like it went mostly on her side.
There we go.
That felt like it clicked.
Yeah.
We gotta
Did that go through, Ashley?
Yeah.
Nice. All the cabinets went on easily onto those French cleats, and if you look closely, this leftmost cabinet has a wire dangling straight down. All I did was drill a hole in the ceiling and ran that wire up into the attic, and I'll tie it into the rest of the system up there. So now that I have all the wires pulled and ready to go, I can start hooking up the valances, and I just trim off all of the casing from the wires. I strip them and get them ready to solder. I decided to start with the most complicated one, which is the one that has the connection between the two sides, and I twisted the wires together that came from both sides, basically making them into one single circuit. I grabbed some shrink tubing from my shrink tubing kit and decided to go with black and red to kind of match the colors of the wires. And I slip those on before I start the soldering process, because if I forget them, I can't put them on afterwards. I solder those twisted connections together, and then connect those to the pre-tinned wires on the LEDs. I slipped the shrink tube over the top of the connections, but before I shrink those, I decided to give it a little test. Those connections seemed to work out great, so I went ahead and shrunk the tubes and then attached the valance. With the middle one done, the other two are super simple. It's just a straight up connection between two wires. Just solder them together and put the valances in place. The last thing to add are the plastic diffusers, and these are cut pretty easily with a box cutter. They're a little finicky to snap in, but you just got to be patient and work them from one side to the next, snapping them in wherever they will, and it takes more pressure than I expected. They're worth it though. It is a big change in the quality of light. Even just adding these little diffusers makes it look so much better, and with that, the lights are done. The quality of light in here is so nice. I love how these came out. And with the addition of the hood and the over-sync light, I just have really even lighting across the whole counters. Now I mentioned at the top of the video that I was gonna explain how to retrofit existing cabinets, and that's honestly pretty easy. If you don't have existing valances, you can basically just do what I did and build these valances, hide all the wires, and you may have to drill through the back of the cabinet to connect to whatever power source you're using. Now, if you have existing valances, or just all you need is about a 1/4 to a 1/2 inch lip underneath your cabinet. A lot of cabinets already have these. You just attach the LEDs underneath the cabinets in the way that I did. You might not be able to get as clean of an install without any exposed wires, but they do make little wire covers and things, which I'll link down below. All the products that I mentioned in this build are linked down below, including a bunch of the tools that I used as well. If you're new to this build series, I've been working on this house for about a year, and there's a whole playlist of videos that you can watch to see this house go from an old 1940s house that's not been remodeled to what you're seeing right now. And we're closing in on the end of it, and I'm working on some limited edition merch to commemorate all the work that has been done on this house. I've been working with the Patreon supporters on the design. It's coming along, it's almost there. I can't wait to share it with you guys, so keep an eye out for that. Thanks as always to my Patreon supporters. You guys are the best, and I'll catch you on the next one.